Hi, in this video, I'm going to solve the problems that show up on the 2019 Math Counts national competition at the semifinal round between Sam Wang and Daniel Mai. I chose these problems because these two students were tied for the longest time. They were tied at 3 apiece, so they keep asking more and more questions. So we have a lot of questions, first of all, and the questions are all really good. So, so that's why I chose them. All right. So now the first question. When 2019 is expressed in base 2019, how many zeros are to the right of the last non-zero digit? So basically, how many ending zero, right? Well, when you're in a base, so like in base n, then every multiplication by n gets you a zero. So the question is, when you're multiplying 1 times 2 times all the way to 2019, how many 2019s are there? Well, the number 2019, the prime factorization is 3 times 6, 673. So in this one, there are a whole bunch of threes, right? There are 673 of them, basically. There are a lot of threes, so if we're going to count how many 2019s, we're going to count how many 673 are there. Well, there are 3 of them. There's a 673, there's a 2 times 673, and there's a 3 times 673 at 2019 itself. And these can pair up with any 3. I mean, there are a whole bunch of 3s, multiples of 3 being out there in that product. So just take your pick, right? So the answer is 3. There are 3 possible 2019s, and therefore 3 zeros. Therefore, the answer is 3. There are 3 ending zeros. All right, next question. The positive number n is odd and composite. If the sum of the digit is 4 and none of the digits is 0, what is the sum of all the possible values of n? Well, if the sum of digits of n is 4, and it's not none of digits 0, then it can only be 1 or 2 or 3. That's it. It cannot be 4 because 4 is even, right? So now we're going to do some combination of all of these numbers. It could be 1, 3, it could be 3, 1. It could be some sort of combination of 1, 1, and 2. So 1, 1, 2, 1, 2, 1, and 2, 1, 1. Or it could be all ones. Okay, nothing else gets you a sum of 4. Okay, so these two are gone because they're prime. And we know that n is composite. That's 211 is also prime. 112 is even. That's no good. So that leaves this. This composite is 11 squared. This is also divisible by 11. So the sum of all the possible n's is 1, 2, 3, 2. All right, next question. When the expression, that quantity 2x plus 3 over x, the whole thing to the power 6 is expanded, what is the constant term? If you expand this out, then you get some sort of binomial coefficient times 2x to a power, and then times 3 over x to a power. And the binomial and the powers here have to add up to 6, okay? And if you want the constant term, then you want the x and the 1 over x to cancel perfectly. So that means you want the third power here and a third power there. And that means the binomial coefficient is going to be 6, 3. Okay. So all it takes is going to multiply this out. The binomial 6 choose 3 is 6 times 5 times 4 divided by 3 times 2 times 1. I'm pretty sure a Math Counts a competitor would have these binomial coefficients memorized. It's one of the things you do when you do competitions. Right, and 2 cubed is 2 times 2 times 2, and 3 cubed is 3 times 3 times 3. And then you sort of simplify, and this is 20, and this is 8, this is 9, 8, no, it's not 9, it's 27. So 20 times 27 is 540, times 8 is 4320. Okay, next problem. A white circular cone is with radius 3 inches and height of 18, is cut parallel to its base to form a smaller cone and a frustum. So if the smaller cone has height 12 inches, so this here is 12, what is the volume of this? Okay, so you do need to know the formula for the volume of a cone, and the volume of a cone is 1/3 base times height, so pi r squared h. And so for the large cone is 1/3 pi r squared h, and these cancel, so you get 54 pi for the large cone. Now the small cone is 12 out of 18, 12/18 is 2/3 in height. So it's 2 cube out of 3 cube in volume. So it's 8 out of 27 times 54 pi in volume. So 16 pi in volume. And the bottom, the frustum is going to be 54 pi minus 16 pi is 38 pi. I don't know if that's the best way of solving it. I mean, it is a perfectly good way of solving it. I don't know if it's the fastest way of solving it because all these competitors have time limits. So I'm not, but that's how I solve it. Yeah, so I'm just gonna pause here and talk about a lot of these problems. When you're steep into the world of competition math, you learn a lot of shortcuts and tricks, and it may not translate so well into academic math where you have to justify all your assumptions, right? For competition math like this, sometimes you go, especially of the kind where you just give an answer without having to explain anything, then a lot of times what you want to do is you go with your gut feeling. And so what if you're wrong? Then if you don't go with your gut feeling, you're not going to get your answer in within 45 seconds anyway. So might as well, right? So yeah, a lot of competition math is done differently from academic math. All right, so this problem, what is the probability that 6 rows of a fair 6-sided die results in exactly one occurrence of each value from 1 to 6 inclusive? This is a straightforward probability problem. You roll a die. You roll it, you get whatever number, then that's perfectly fine. So you got 6 out of 6 chance. Okay, but the next roll, you cannot repeat the number you already had. So you only have 5 choices left, right? So that you only have 5 out of 6 left. Then the next roll, because you cannot repeat the last 2, so you only have 4 out of 6 and 3 out of 6 and 2 out of 6 and 1 out of 6. And this is the answer. And the point, so I guess you just gonna have to simplify this. 3, 2, 5, 6. The 4, simplify 2 of these, so you get 3, 3. So you have 5 out of 9 times 36. No, 32. So it's 5 out of 324. There we go. Next question. A rhombic dodecahedron is a polyhedron with 12 rhombi for its faces. How many vertices does this polyhedron have? This is actually a very straightforward problem in terms of competition math, because In a regular classroom, nobody teaches about polyhedron anymore, I don't think. But for competition math, these polyhedron faces and vertices and edges are bread and butter. So I'm pretty sure you have to know this formula. That's a formula that relates the number of faces and number of vertices and number of edges on a polyhedron, and it is F plus V minus E equals 2. You just have to know this formula. This is a 12 faces, a 12 face, plus the number of vertices that they're asking for, minus the number of edges. Well, every rhombus has 4 edges, right? But each edge is shared with another rhombus next to it. The vertices, we're not sure how many they're sharing, but the edges, we know for sure each edge is shared between 2 faces. So there are 12 faces, 4 edges each, and they're being shared 2 and 2. So it's like that, and equals to 2. These cancel to 2. So that's 24. So 12 plus V is equal to 26. So V is 26 minus 12 equals 14. There we go. All right, next question. If B and C are positive integers such that the square root of 11 plus B rad C plus square root of 11 minus B rad C is equal to 6, where B radical C is in simplest radical form, what is the value of B squared C? So 2 things. Number 1 is they're asking for this value only, okay? And this value is just the square of that value, B radical C. So in other words, they're not asking a question specifically about the value of B and the value of C, 2 values separately. They are just asking about that quantity. And matter of fact, they're asking about the square of that quantity. So I'm just gonna write this as one letter, X plus radical of 11 minus X is equal to 6. Now, what I'll do is I'll do straight classroom math on this. Sometimes when you have radicals, when you have multiple radicals like this, you may say, I don't want to just square both sides because it gets messy. But in this case, I can see that the plus X and the minus X will cancel. I can see that when I multiply these 2 radicals together, I get a difference of squares. So things simplify, so I feel good about just squaring both sides. All right, I'm not sure if the whole screen is showing. Well, yeah, okay. All right, so square both sides. Then what I have is 11 plus X plus 11 minus X plus 2 times the radical. Okay, but that radical is the product of these 2 is a difference of squares, so it's 11 squared minus X squared, and these cancel, so I have 22 plus 2 times is equal to 36. That's 14. That brings us down to 7. So 121 minus X squared is equal to 49. So X squared is 121 minus 49 is 72. All right, next question. A trapezoid with vertices at 0, 0, 3, 1, 3, 8, and 0, 4 is divided by the line y equals mx. All right, so here's a trapezoid. Divided by the line y equals mx into 2 regions of equal area. What is the value of m? Let me call the height at this point, or the y value at this point is y. These 2 areas are the same, so I just need to find the area of this trapezoid and that triangle. All right, in a way, I only need to find y, and then that would do it, because this is 3. So the slope is y's overrun, so it will be y over 3. The area you're going to have to imagine looking at it sideways. So this is actually the height here. So imagine look at things sideways. So that's the height. Yeah, letter H sideways. Okay, so area of the trapezoid is 1/2 the sum of the bases times the height. The sum of the base, I got this base on the left is 4, and the base on the right is 8 minus y times the height. In a way, I really don't care about the height because I can think ahead and I see that the area of the triangle also involves the same height. So it doesn't matter what it is. I mean, it's 3, but I don't care. And I don't care about 1/2 either because they both have the 1/2. So I really care about is that the base is here. The base for the triangle is y minus 1. And the 1/2s are the same. The heights are the same. So all I need to know is that the bases are the same. So I have 12. 12 minus y is equal to y minus 1. So 2y equals 13. Y is equal to 13 over 2. And the slope is y over 3. So it's 13 over 6. All right, next problem. If x is a positive real number, how many possible integer values are there for this quantity? Okay, so if this is a real number, then I can write it as some sort of k. 14x minus x is equal to k. Okay, and now x is a positive real number. So that means x squared plus 14 is larger than x squared. So this square root is larger than x. When you subtract x, you get a k. So that k has to be greater than 0. So they don't say how many possible integer values, but I deduced that it must be positive integer values. Okay, so I worked this out. I move x to the other side and I square. I get x squared plus 14x is equal to x squared plus 2k x plus k squared. The x squared, subtract both sides. I'm going to solve for x out of this. 14 minus 2k x is equal to k squared. So x is equal to k squared divided by 14 minus 2k. If I want this to be an integer value, all I need to do is to plug k in here and calculate x, and I put x back in, I should get k, which is an integer value. So how many possible integer values are there is the same as how many possible k values are there. Well, how many possible k values are there? Well, if with no restrictions, then infinitely many. But there is a restriction. The restriction is that x has to be positive. So this has to be positive. Well, k squared is already positive. So that means 14 minus 2k has to be positive. That means k has to be less than 7. And together with this condition here, that means k has to be between 7 and 0. And so that means 6 different values of k, 1, 2, 3, 4, 5, and 6. Okay, Lindsay randomly selects 2 distinct days each week to go rock climbing at the gym. Jess randomly selects 3 distinct days each week to climb at the same gym. What's the probability that they both be at this gym on the same day at least once any given week? Right? Anyone who's taking an intro probability class will have seen an at least once problem. And it's really hard to do an at least once probability straight head on. It's easier to think of it as 1 minus the probability of not at all, right? Of all different days. If they all have different days, then that's the complement of seeing each other at least once. So how can these 2 people choose 2 different days? Well, Lindsay chose, I'm not sure if it's a male Lindsay or female Lindsay. Let's say female Lindsay. So let's say Lindsay chose 2 days. So that leaves 5 days for Jess to choose, right? If Jess is gonna avoid Lindsay, then Jess only has 5 days to choose. So out of 7, he can choose. He got 5 choices for his first day to pick to go. 4 for the second day he could go. Out of 6, 4 out of 6, because the one day that he picked at first is no longer available. And once Lindsay has already chosen 2, and he has chosen also 2, then he only has 3 left out of 5 days of the week. So you simplify this out, get 2 out of 7, and so 1 minus that is 5 out of 7. Next problem. Perfectly spherical drops of water at radius 1 millimeter drip out of a leaky faucet at a steady rate of 500, a perfectly cylindrical bucket, diameter 20 centimeters. So this is radius of 1, and this is 20 centimeters. I'm gonna write it as 200 millimeters and a height of 30 cm, so I'll write it as 300 mm. And so now how many hours? Well, that means I'm just gonna work this straight, okay? I don't know of any trick of doing this quickly. The volume of a drop is 4/3 pi r cubed. So it's 4/3 pi. So let me move it over here. So it's 4/3 pi per drop. And you have 500 drops per minute. And they're asking for hours. So I might as well multiply by 60 now. And 500 times 20 is 10,000. And times 4, so I get 40,000 pi per hour. Okay. And what's the volume of the bucket? The volume of the bucket is base times height. So pi r squared h is pi. R is 100 squared times h is 300. So it's 3 followed by 1, 2, 3, 4, 5, 6 zeros. So if I'm going to divide this out, then I cancel the 4. 1, 2, 3, 4. So I have 300 divided by 4, and that is 75. 3/4 of 100 is 75. Okay. Next problem. The first term of a sequence of positive numbers is 1, and each subsequent term is 10 more than 4/7 of the previous term. What is the 219th term of this sequence? All right. This is one of those things where I just say, you know what? There's no way I can do this normally. Okay, there's no way I can actually compute the 219th term exactly. Okay? We're talking about a sequence that is defined recursively as a sub k is equal to 10 plus 4/7 times ak. And if you've done enough of these problems, you know this doesn't simplify at all. 4/7 times 10 plus 4/7 times 10 plus. It doesn't simplify at all. There's no way I can do this to 2019 term. But this is competition thinking. There's no way they can ask me to do that either. So there's got to be a trick here. And the trick here is that if I assume that the sequence converges very fast, then the 219th term as a decimal to nearest tenth. So they're not asking for the exact value, they're asking for an approximate value. And if the convergence is really fast, then by the 2019th term is probably equal to the limit. Okay? So I will just give them the limit, and I hope that that will be the 219th term to one decimal place. If it converges at all, then the limit is going to be defined by the fact that by the time you get to the limit, the two terms are the same, but practically the same, or well, at the limit, then it's exactly the same. Then I just solve for A. So 3/7 A is equal to 10. So A is 70 divided by 3. So it's 23.3 repeating, so 23.3. So yeah, in competition, that's what you should do. Now, outside of competition, like I'm here right now, does it really converge? Well, I think so. You have a sequence that goes, first you take 10 and you plus 4/7. So the next term, if you think of it as y, then it's 10 plus 4/7, the previous term. This slope is less than 1. If I draw the line y equals x, then it'll cross this line. I'm starting out with 1. Okay. Then the next term, then that means I use the y equals x term to find my corresponding value. And then I do 10 plus 4/7 of that, so I'm up here. So this is the second term. Well, to do the third term, I find the x that's equal to this. So that means I move over to this until I hit the y equals x line. Okay, that will give me an x that's the same value as this. And then I calculate 10 plus 4/7 that, which is this height. So basically, in order to find the next term, I just zigzag between these two lines. So yeah, it converges, and it converges really fast. All right, next question. How many simplified common fractions of the form A divided by 2019 are there strictly between 0 and 1? All right, 2019 again. We already know that it's 3 times 673. Simplified fractions between 0 and 1. All right, so A could be anywhere between 1 and 2018, right? Because at 2019, it will be equal to 1, and then we're not allowed to have that. Some of these will cancel and some of these won't. If they cancel, then it's then it won't be of this form. Okay, it won't have 2019 in the denominator. So I count there are 218 possible fractions. Okay, some of them will simplify. Which one simplified? We cancel the 3, then the denominator will no longer be 2019. And how many of those are there? 672 of them. Okay, because again, the 673rd of it would be actually equal to 2019, and we don't count that. And how many times do we cancel the 673? 2 times. So I want to subtract these 2. There's lag in Zoom here. All right, unfortunately, Zoom disconnected me right there. But it's also good because it was the last problem of the semifinal round. Daniel Mai correctly answered that question, and he moved on to the final. So, well, I've enjoyed making this video with all these problems, so I hope you liked it too. Thanks for watching. Bye.